Alright, so we have the tool set up. Now let's move on to the tool changer, the most sacred part of this entire setup. The mechanism that binds it all together, that literally everything works around. You know, from the pictures I thought this had a plastic casing on it, but it's actually steel for reducing EMF. But yeah, that's good. And look at this cute little, oh wow, tactile sensor with a little grommet around it to prevent any sort of dust intrusion. Omron, it's a quality switch right there. That'll outlast the printer. Well, maybe. Lots and lots of duties, lots of cycles of what you traded for. So this looks really unique. I wasn't quite expecting this because I knew from pictures that I'd seen these alignment rods, but I didn't know how they were being used. And I thought that something would actually like clip in or enter in between, but it's even, I guess, more precise than that, where the sphere, so these are embedded spheres, basically ball bearings embedded into these plates, and then press fit in to secure them. And so what that does is whenever you have one line up, you have like from any angle it would go left to right, but like it'll slide the other direction. It's got a little bit of weeble wobble room, but the other direction crossways, it's a very high tolerance and very smooth, and it just begs to be centered, like really hold that center then. And it does a pretty good job of putting that. I'm curious though, because they have these two pieces in the bottom, and then the top is actually like a left to right. So I guess they're also relying on the shaft maybe to help a little bit, because like this top piece isn't going to have any side to side, but these bottom ones will, and that's where like your torque's going to occur at. But apparently it's been through the ringer enough that they thought that this was acceptable. Sealed bearings again, great to see, and I mean, it seems to fit up pretty nice. I'm excited to see how this feels when we actually have the motor, this little servo set up for the locking mechanism, of which going to go inside the faceplate and it just turns and it locks it in. I think I showed it earlier, but I'll probably dig out a faceplate later to show you how that works. But there's actually ramps that as the servo rotates, it pulls the shaft forward because it goes up this ramp, and that ramp's designed into this faceplate, so like it causes a spring tension. There's actually a spring tensioner on the shaft, so it really hugs that faceplate nice and tight up against the assembly, and the shaft will just slide in and out of this bearing, which is a little questionable. Much better to see a bearing in there than a bushing. We'll get to doing some fun stuff here. Okay, so first off we have what is called our faceplate, and we're just going to casually, it's nice where it has this little alignment pin, and then it's actually got an alignment pin on both sides, and then your screw hole. No sign of what screw to use, but it's going to be one of these. This is an M2.5 and an M3, so whatever fits in this hole is going to be our screw of choice. That's not really going, so I'll try the M2.5. Doesn't like that either. But it is a socket head cap screw. Just had to have the right touch. Lots of small components, lots of steel parts. But it's all good. Well, you know, if I'd paid any attention to the fact that this has thickness that was not negligible, I would have realized that I had to use the longer screw, and it would have just, there wouldn't have been a search. Go get our Loctite back, and let's get a rag, because we know how messy I like to get. Alright, pulling tight, and now we have a nice little alignment pin here at the bottom. Guess we'll find out what that aligns with, or feels for, but yeah, that's fine. That's looking good. Alright, so we're just going right for it apparently. We get the button head screws here, and then there's going to be 4 of them that we're going to use to mount to our carriage. I will go ahead and move some of this, and I'll kind of split the bench here so that we can get a good view of everything going on, hopefully without losing too many things. I think part of my issue with this is going to be the camera is going to want to focus up here. So I'll try to do as much of my work as I can up here. So with this, it just wants us to run wires off to one side here. So we'll casually suggest these two go hang out over here, not be a stranger of a screw. should be good. Loctite, and alright, so it appears that the belts are kind of interfering with placement, so I'm gonna kind of tuck them under here as I slide it in, and then once they're captured, yeah, one other thing to address that they didn't mention is there's a slot here for putting that shaft in. These need to be like brought towards the shell of it as much as possible as to not interfere down here. And so I think this will be enough. I guess we'll find out. Might take a couple iterations. Well, hey, looky there. I got lucky the first try. What I'll do is I'll dip a finger here. But it looks like I'm going to have to, but I'll probably have to do some cleaning and polishing once I'm done. But that's a good amount of screw at least. It's good, like 4 or 5 threads. Nothing really to complain about there. Let it line up, bring it in, just about snug. Here, I'll get you some more light. Here, there, more shadow, I don't know, one or the other. Some more Loctite, place without tight, last little bit, and we'll have our 4 screw. A lot of this is dried up on the rag at least, so cleaning up with it is a little bit easier. And we'll just give her a bit of a polish here. Nothing too special, but nothing like she was. Snug, but not more. So now we have motor and small gear. And so it's saying round recesses. And I think that's actually to get it a little bit closer to the motor due to that shaft, as you can kind of see here. Fit right on to the shaft, nice and tight, apparently. I don't know if that's a good thing or bad thing. So there's just a hair bit of tolerance issue. It looks to be, so these nodules are fine. It slides on the shaft fine that way. So for whatever reason, there's just a bit of an issue with getting this started. It looks like it's gonna go on with a little bit of extra love. Just there we go, nice and tight. Go find your super glue that we've been using way too much of. Cap this bad boy off. Personally, I do highly recommend using gel super glue. It has worked fantastic for this. So I just filled in the entire cavity with the gel super glue. Now we have a symmetric plate here. Some 2.5 head cap screws. Those are the ones that I tried using earlier. Failed miserably. It's probably actually Loctite just a touch. Make sure that it is truly symmetric. They do have some pins here, which the cutouts are there for, and so we're just going to make sure, I guess they're not pins, they're little like nubs, so we'll make sure that those are accounted for whenever we tighten these down. There's 4 all the way around, so there's 2 on the top and then 2 on the bottom. Caveat for those, snug but not tight again. Now we'll grab our back plate and 2 standoffs. There are 6 total, and we get ourselves some. I tried not getting my finger that time. Failed miserably, but I tried. I'm gonna count it for a halfway success. Because that's the American way. Nah, I'm just kidding. We'll get these finger tight, and then we'll do a finger tight plus just a touch. And we have our motor. Looky there's a nice little motor slot, just like made for it. We get some pan head screws here. Now this, I'll at least rotate it for you a little bit here. But what we're going to do is stick this on here, which we still have even more belt issues. Kind of concerning, really. So. Directions do say to make sure that it's like square. I'll try, but in all honesty, there's only so much I can do about being square when no alignment pins or anything were provided. And I'll just use that same monkey wrench again, and ever so gently. I'm not sure if these standoffs are steel or aluminum. I wouldn't be surprised if they're aluminum. I think it is actually stainless. It's good. This is an expensive little piece we got here. And then what we're going to do is just stick this in the end of the shaft here. Just get started. And then we're going to take one of these shafts, slide it through. And so this is actually going to be the locking mechanism shaft. So it's good to see that that's actually a stainless steel part. That'll have a nice life to it. And we'll get that mostly centered. Some torque. We got our little E-clip here. We don't do it fancy side out, where it's got like a little bit of rounded where it was stamped from the top side down. Well, it says apply lube. I'll be back. Get some lube. Now I'm gonna be real careful with this. This is just a silicone lubricant. Just nuts at how slick it ends up being. Guess we'll add some. I have a feeling bushing may have been better in this circumstance. I don't know if y'all have used some of this lubricant before, but I'm pretty sure a person could put it on the bottom side of their shoes and turn them from something grippy into ice skates in a matter of seconds. Randomly stick a screw in here, it seems, on the underside. I'm sorry, I won't be able to really show this to you. On the shaft on the underside, you have to pull it out, and this is basically the stopper that keeps it from going one way or the other too far. And I mean, it's the only hole that's threaded and sideways in the rods. There's really only so much a person can miss about it. Torque it until happy? No, maybe not. It doesn't exactly align with anything. The servo itself probably already has preset 90-degree one rotation, since it's probably a 2-to-1 or 180 degrees, something like that, so that it only turns a certain amount. Alright, so now we're going to lube up this side where there's another bearing that's going to be, because that's definitely how we do this. They did say grease, and I'm not listening to them because I didn't have grease on hand and I wanted to complete this. Like, I'm almost sorry, but not really. I might be sorry later. Time will tell. So this is the part that I'm pretty hesitant to be using silicone lubricant for. But as things have been said before, there was zero forewarning. I'll happily tell them to send me one for free as a replacement, and if they don't oblige, then I guess I'll buy it. But no, the one bearing raised closer to you, this is a flat bearing for thrusting. The one bearing raised closer to you actually has a slightly larger diameter, and that's so when it's pushed up against that wall, the shaft can slide in and out based on the thrust of it, and this won't be affected by that shaft at all. It will only ride against more of an outer edge, and so it will stay still, allowing it for the bearing to actually like turn against it. Hopefully they accounted for the fact that it might also rub against the center of the bearing behind it. At this point, bearings are like way overrated. I feel like just throwing in some bushings would have been about as good and probably would last about as long, due to just design constraints, especially when it's like a constant pull item like that, where it doesn't need any amount of tolerance. It just doesn't make sense to have a bearing there. There exists plenty of very cheap and just as long-lasting thrust washers, or whatever you want to call them. Like, I get it, they went like way over, but I feel like the engineering might not have kept up with the effect of what it takes to actually utilize these highly rigorous devices such as bearings that are meant to last a very long time. Plural screws fit into the bronze gear when there's only one screw to fit in. Give it a little bit of Loctite, get it started. So this is actually going to act as a thrust item for linear motion, and it all rides on a single set screw, which is fine. It does have a faced off place for it to rest. It just might get a little interesting trying to get this to work out. I'm going to face this towards you guys, the flat piece here. Oh, that's alright. They did this part right. So what they're having us do is actually use the screw here to assist in assembly. One of the first things that's helping with assisting in assembly, but I will absolutely take it. I'll just go ahead. I mean, it really doesn't need any Loctite, but put it on everything else at this point. It might as well. So then this spring will go on first. Be careful not to move that, and then this gear is going to go on and generally towards the flat spot, but we'll look into taking care of that here in a bit. But we don't have to worry about that gear moving back and forth at all, so we're not going to lubricate him, but we will lubricate everything once this is all said and done. And I'll just let that rotate around for that screw that we put on the inside. Lock it in as I tighten this, and then right now this gear will actually rotate. It would. Alright, the shaft rotates inside the gear. I have no idea if I'm going to find that flat back or not. I mean, I will find the flat back. That's just, so I want to go down until I feel some sort of impact with the screw, or with the shaft underneath. And then I will sit here and I'll rotate this until I might find something that will stop it going one way. I'll go back the other way. And there we go. I found that flat. And so you just sit here and you rock the screw back and forth as you tighten. And it will find the middle of that flat just by itself. Really don't need anything special that way. Torque it just enough. And she will be set for a long time. And just to wrap this up, I'll throw some lube up in here. Wipe the slobber off the jaws, and it looks like now we have a pretty little cover we can put on. No idea where it is, but we have one somewhere. It was a printable. Now I'm not gonna print that one right now. Oh wow. I think someone was starting to learn here. But they actually highlighted where the screws are supposed to go. Screws and grub for brackets. Got 2 brackets. And so that's another piece that I need to put off. But basically there'll be a bracket that comes up here that'll have the brace similar to these sticking up, and then that'll have a ear running up and over to right here, which will have another bracket. Print that and some covers, and that will be the end of it. But as far as this goes, it is mechanically set where I can drive it from this end. I want to see if there's a set stop here. So I think because that was continuous, what we're going to end up having to do is we will tell it where up and down is, and then slowly we'll tune it in. And it being a servo, it will hopefully have an encoder somewhere on it that will be able to say, hey, I am here every time you start it up, and I won't have to like relearn that every time. Well, I guess it'll always go back to a certain position if done right. Let's go see if it'll kind of sort of take apart. There we go. That's how she's gonna run. It all hangs out here. That'll be good. You got your Bowden come out of here. You got control wire for here, and you have control wire for here. 3 separate wires. It's all good. Slide that in. Give her a good old rotation here. Aha, found it. This is why machines do this, not me. I would lose track of it too fast. And just like that, she's set. And the nice thing is, like, we already know that it works because we ran this dry. We just have the exciting things left to do. Boring? Exciting? I don't know. How would you define it? You probably couldn't even see any of this. Grab it, pull it off, do some printy things, come back, slide it on, have it let go. I like that. It's gonna be good. It's kind of, I mean, it makes sense that this is sticking out further and stuff, and tools will be all over the place. I'm excited. I don't know about you guys, but I am like just so excited for this. Alrighty, we are on to round fun. We're getting real close to finishing this up here. I'm gonna go ahead and mount. We got a couple of cable holders here. I'm gonna mount these. That is gonna be it as far as setting this up. I do have half a cover for this, but it didn't quite print right. Found out that filament that I'm using bridges exceptionally well though, all said and done. Basically half the part ended up not even touching the print bed. Like it just delaminated from the one side. It was split down the middle, and then the top was supposed to fill in completely. And so it got to the point of filling in the top, but it was missing half the side. And it had probably about 30 or so layers in order to compensate and basically bridge out into no man's land a good like 3/4 to an inch away from the nearest building block. Not only that, I mean, it was going out, going over, and then coming back, and it was succeeding. It was just phenomenal. Here, I'll show you here in a second, but I was very impressed that any filament would allow such a print. I mean, it didn't just go out, print a right angle, print a second right angle, come back, and it was like happy old days, and it worked just fine. But it did, after I would say maybe 8-10 prints, manage to string enough hobglob out there, maybe closer to 20-30, but it was able to put enough random stuff out here and kept trying that it was actually able to start a solid formation out here, and then it went to start bridging, and it bridged out to this direction. So if it hadn't succeeded, it would have made an absolute mess, but it actually succeeded in bridging a massive overhang. I mean, it's not a usable part, but it succeeded in it, and then succeeded to finish off the top pretty nicely. I mean, not phenomenal by any means, but definitely not going to complain, especially seeing as it's the circumstances of which it was under that it printed. I'm half tempted to put it on the machine as is. It's the top side that's distorted, and I don't want to filament. I wanted to just print another one here because it, despite being proud of it, it's not something that I'd be too thrilled to be displaying as front and center and main on my main assembly right here. Basically, it would come up and just have a flat part on my changing head, and then it'd be open down into, like, you'd be able to see down into here just because it didn't print there at all. Not that it's necessarily a bad thing, it's just I like completeness and wholeness, and I think it would bother me to have that open and exposed. I'm actually tempted just to leave this completely exposed anyways for satisfaction of viewing, or maybe make like a small frame around here or something. Not entirely sure yet. I mean, if we're going to have such a massive and important mechanism here, I am not opposed to keeping it on display. Not one bit. So there we have it. Next section, I'm going to go into wiring everything, and that's going to include our hotbed, and then at the very end, wires will also include Bowden tubes and the entire bunny ear assembly and whatnot. I believe it will also include sidewalls, just because that's where the spools get mounted, and there will be Bowden tubes running to certain locations on the sidewalls. So those will have to be in place for this next video. So I'll just go ahead and do that in the next video. But as for this video, there is, while not fully functional, if we set our alignment pin here and our keeper pin, in order to line up, we do have an ability to go from one, touch it, it aligns out, over, and mate with our second tool, which is fantastic. I will say, by the looks of things, if it ever comes down to making any tools for oneself, the #1 priority for aligning anything here, that the top of this plate, or I guess the orientation of this plate, is set up to mate perfectly with this tool head. And I think they actually did it, and this looks right because I can look at the V6 hot end, and you can see how the top piece runs across the Delrin like a tool mount or hanging mount, but this actually aligns with the top surface here, and so that makes it really nice for doing any sort of measurements. You know exactly where this plate is going to be as far as height, because you need this to be perfectly level with however you mount it to your system. This plate, you can place your hanging Delrin piece as much above it as you'd like. Going below being perfectly flush with the top is going to be very difficult, seeing as the parts that they provided only hang to be flush with the top. But you can go above as much as you would like and build something out here, and that's perfectly fine. And that's very clever, and it makes working with this, it's going to be a breeze for making anything in the future. Of course, there's going to be some extra dimensioning and whatnot going into this, but that's fine. It's all part of the day job. Otherwise, I am happy with how this is coming together. Stay tuned, and we will get to this next stage in this next video. I appreciate having you, and I will see you next time.